Start. Okay. So in this experiment, we are going to discuss about a common emitter configuration of BJT output characteristics. Right? Common emitter configuration of BJT output characteristics. In the previous video, what are the terminals of the transistor I told? One is emitter, another one is base, another one is the collector. Now you able to see here what is the aim of this experiment: to study the output characteristics of a bipolar junction transistor in common emitter configuration and to calculate the current amplification factor, that is beta. This beta is also known as HFE, forward current gain. HFE, forward current gain, output current by input current, that is, and output resistance also we have to calculate. So these are the two aims are there. One is current amplification factor, one more is output resistance we need to calculate. What are the operators? Operators are same. One transistor we need, right? So two power supplies we need here, two power supplies, and two resistors. One is 33K resistance, another one is the 470 ohms resistors. One is DC voltmeter, one is DC ammeter, and patch cards. These are the operators. So what is the formula? The formula is HFE is equal to forward current gain or current amplification factor is equal to delta IC by delta IB at a constant VCE. Constant output voltage we are keeping the constant here. So that is the knee voltage you have to say. IC is equal to beta into IB. Output resistance is equal to delta VCE by delta IC at a constant IB. Now we able to see the circuit diagram. This is a common emitter NPN transistor. Already I told, if it is the BC107, that transistor is NPN transistor. If it is AC128, that transistor is PNP transistor. You have to take it as a tap or notch. So nearer to the top, the terminal is emitter terminal, the subsequent terminal is base, another again subsequent terminal is collector terminal is there. Now what is our ultimate goal? Common emitter configuration. Emitter is common to the input, emitter is common to the output. Clear? Now based on this circuit diagram, we have to connect the connection. First you able to see power supply positive. Power supply positive, you have to connect it to the 33K ohms. 33K ohms resistance you have to connect. So 33K ohms resistance next end, you are going to connect with IB, that is the milliammeter, right? So that milliammeter negative, you are going to connect it with the base terminal of the transistor. Base terminal of the transistor you have to connect. Emitter is you have to connect it to the ground. That next power supply next end you have to connect it to the ground. Power supply this end also you have to connect it to the ground. Now you able to see this collector terminal you have to connect it to the 470 ohms. This collector terminal directly you have to connect it to the 470 ohms, and then this 470 ohms, this IC, after some time I have to take this IC. First you have to connect the direct connection of this power supply. This is the VCC power supply. So this 470 ohms direct connection of VCC, the latter this power supply I have to connect it to the ground, I have to connect it. Clear? Now this voltmeter where we have to keep, this is output voltage VCE, ground, and this one I am giving to the ground, the power supply positive, voltmeter positive terminal you have to give to the collector, right? This is the circuit diagram. Once you have to apply the circuit diagram, first you able to set here. Which one you have to set? This is the output characteristics. For the observations, IB, base current, input current you are going to set. Input current IB. Now the switch on it is, this is the input power supply. You rotate this one, you have to set here. So what is this IB? This IB is equal to 20 microamps you have to set. How many microamps you have to set? 20 microamps. Clear? Right, you able to see 20 microamps you have to set it. Pairing so 20. So 20 microamps once you have to set. After 20 microamps you are setting, once you have to set the 20 microamps, maybe 19.4, so right, 20.1. So 20. Once you have to set, so this is the IB current is fixed 20 microamps. This is the micro, upside is the micro, downside is the milli. Right? Now, once this voltmeter, now you have to see this current IB, current meter you have to remove here. So the switch off this one, this current meter where is connected, once you have to see this current meter is from here, this current meter is from the base is there. So now this current meter I am removing, because where I want to give this current meter, at IC I have to connect, IC, at IC I have to connect. So that's why this power supply end also you have to remove. Next, take one jumper, right? You have to take one jumper. So this jumper from the resistance one more and two. Wherever we are removing that, this is the resistance one more and two. From base you have to give. Where you are giving? Base. This is the base. Clear? Right. So wherever we are removing the IB, there we are giving, this is the jumper. Which one it is? Jumper I am giving. This jumper I am giving here. After giving this jumper, what we have to do? So now we are connecting this collector terminal to 470 ohms you have to give. This 470 end you able to give that. This 470 end IC you have to give. This IC negative terminal you are going to connect to the power supply positive. IC negative terminal you are going to give the power supply positive, right? Power supply positive how to give. Now circuit is completely completed. Now you able to see, now switch on, right? Once you have to switch on, now you see the observations. What observations you have to see? First you are taking this, the IC. Now you apply here IC, you have to apply 0, you have to apply first. Here you have to take the milli, because in micro that out of the range it is coming, out of the range it is going. So that's why you have to change into the milli. Clear? Because it is it is the output characteristics. So first you able to take the 0, you have to apply. IC is equal to 0 milliamps. Now you have to apply the 1 volts, you have to apply direct. How many volts you have to apply? 1 volts you have to apply, right? Why it is coming the negative? Because it is a reverse bias. Output bias is the reverse bias. You are getting the negative one, only you are getting. Now you have to apply the 1 volt. What? How much you are getting? That is the 37.4 milliamps. Now you get, again you have to apply the 2 volts. You have to apply. How much you have to apply? 2 volts you have to apply. Correct? So again you are getting 37 point something you are getting. You have to take the 3 volts you have to apply. So 3 volts you have to apply. 4, 5 volts you have to apply. So you increase that one. So right. So now you able to see 38 it is coming. So based on this voltage, this current is increasing. So that current is stably it is coming. Once you have to see here how it is coming. So 1 volt we have to apply. So 2 volts we are applying. For 2 volts also we are getting the same thing. For 4 volts you have to apply. So for 3 you have to apply. So that is the 3, how much? 34 we are getting that value. So now 4 you able to see. 4 you have to see. 34 only we are getting the 4 also. For 5 you have to see. 5 also you are getting the 34 only you are getting. 5 also. And 6 you are getting 35. You are getting the 35. For 7 you are getting the 35 and 8. So similar fashion, once you have to take the graph, so IB is equal to 20 microamps I have to take. So once it is increasing, after increasing that it should be the stable it will come. The similar fashion, you switch off this. Now again you have to go to the similar IB, you have to set it. So now you have to take this, remove these wires, you have to remove these wires. After removing this wire, wherever we are keeping this jumper, so that jumper is resistance to base jumper is there, there we have to connect the, so which one you have to connect, that IB you have to connect, there you have to connect the IB, so that IB is uh, IB you have to connect, that IB you have to connect there, so IB you have to connect the IB, clear, you have to connect the IB you have to connect it, right? After connecting this IB, now oh my god, right, so take the cutter and do it, because I'm rotating that wire, so that's why it is not coming like that. So now you cut it, so simple cutting it is. Now you remove this, you are going to get it, right? So you are giving, otherwise another one I have to use, another patch card I am using, right? So base I am giving, this one you have to give to the base, clear, this is the base I am giving to you. Once you have to take the base, next this power supply positive terminal I have to give to that resistance another end, you have to give power supply positive terminal, resistance other end. Now you switch on this. Once you have to switch on, again you have to set here, so IB you have to set, the previously we set 20, so that is changing into 19. Now you have to change 40. How much? 40 you have to change, clear, 40, 40 you have to change, 40 you have to change. Now switch off and you fix it. So this IB you have to remove, so I am fixing the IB 40 now, right? So now you have to take this IB, you remove this IB from here, and you have to keep the this ammeter here. So take one jumper. So what jumper we are taking, this IB I am removing from the base. From this you have to remove it. You keep that jumper. That jumper is resistance to base. Wherever we are ammeter is removing, there we have to replace the jumper. I am replacing the jumper. Now you connect this IC, you have to connect this positive terminal to the resistor, this negative terminal, you are going to fix it here. Clear? You are going to fix it. After fixing this, so what we have to do? Again we have to switch on. So after switch on, so now you able to see, you have to take, this is the milli you have to apply. So this one you have to rotate. This is the VCE. VCE 0 you have to apply first. For 0 you are getting the 0.1, that is the value 0.1 is there. Now you have to increase 1, you have to increase, right? How much you have to increase? 1 you have to increase. If it is 1, how much you are getting? Once you have to see, for 1 volt 141.4 we are getting. So next 2 volts you have to apply. So apply the 2 volts, how much you are getting? Once you have to see, for 2 volts also 141.7 we are getting. For 3 volts you have to apply. For 3 volts we have to take, that is also approximately 139.0. For 4 volts you have to apply. For 4 volts also you have to get 136.4, and 6 volts you have to apply. 5 volts also we have to get 138.9. So next 6 volts or 7 volts and 8 volts and so on, you have to take approximately 141 is maintained. For you have to take the graph for VCE versus IC at fixed IB, you are going to get this one. This is the, so for a IB 40 you are getting this curve you are getting. Once you have to take the curve, what we need to calculate? Here two things we have to calculate. First beta we need to calculate. How we have to calculate the beta? For vertical line you have to do, this is the IC2, this one is IC1, delta IC is divided by, so which one we have to take? This is IB is equal to 40. This one IB1 we have to write it is IB2. This one we have to consider as IB2. So therefore beta is equal to delta IC is divided by delta IB. This is the current amplification factor. Next you find the slope, right? You find the slope. Slope is equal to what is you are getting? Delta IC is divided by delta VCE at a constant IB we are getting. The reciprocal of the slope you have to write it is, that is output output resistance we are getting VCE is divided by delta IC at constant IB. So therefore we have to write here, this one we will get 50 to 500. So HFE will get forward current gain. Output resistance, how much it will get, that output resistance you have to write. What is the unit of the output resistance is ohms. Like this we have to calculate the transistor output characteristics, means output voltage versus output current when input current is constant. Clear? Like this we have to do in our laboratory. So please share, subscribe and like our YouTube channel. Thank you so much.